Cool. So, Friday, the only one at 8 o'clock in the morning, so thanks for making it here. And sorry for last minute misunderstanding. In fact, I sent a message via issue tracker as opposed to the Blackboard thing because Blackboard doesn't really work with me, or I don't work with it, or one or the other way because we hadn't used it this semester entirely, so it didn't quite work as expected. Anyway, good, what else? Any special things today? Does anyone know the significance of the day today?
Friday.
Yeah, apart from that? Yeah, it's good, that's good. If you look beyond the horizon, do you read news from time to time? Sure you do. No? Well, anyway, it's Chinese New Year today. So if you meet your friends that have cultural roots there, so remember to wish them Gong Si Fa Chai, I think. Anyway, so, but that's a sidetrack. Beyond that, on a more important note, there you go, that's the more important note. We also need to think about wrapping up Android to some extent. So I hope this is streamed. Stream people, hello. So the idea is that we have been looking at Android, and again, as we talked about in the class briefly, it was largely about being a framework that sits on top of Android and has mostly 4 basic application components, 3 of which we covered. What were those again and again? Because that's a good exam questions. Sorry, it's only one question. Which application components did we cover in Android? That's the kind of time where you interact with me and stuff, so just a hint.
Activities?
Yeah. Anyone? That's an open question, so it's not.
Volley.
Sorry?
Volley.
Volley is a specific library for networking, but that is like any other library, but it's the preferred one for networking, admittedly, that's right. But networking itself is not seen as an application component, it's just the functionality. Sorry?
Asynchronous tasks?
Actually, technically no, but actually I like your view, because it's the only concept that actually allows true self-managed asynchronicity, but it works across all application components in principle. So it's not the one either. But what are the other? They're a bit higher level. So async is a bit lower level already. So again, what were the other 2 ones we covered?
View.
Sorry?
View.
No. What did we talk about last week to some extent?
Storage.
Close. There's something related to storage. There was one particular case in storage, which is also considered application component. There's a type of storage, but that's just built into the activity, basically, right? So, but there was a distinctively different abstraction that you could use to implement your own storage. What was that?
SQLite.
Sorry?
SQLite.
But SQLite is a given solution already. So, but how do you build something like SQLite, right? In Android, what would be the interface you would be using?
Service provider.
It's not called service provider. It's called anyone? Collective intelligence and stuff. So you're 50% there. Storage related. Last thing I talked about in the storage class. So that's so much about my lectures. Not sure if anyone attends to them, but if you have an exam by any chance in this paper,
Content provider.
That's right, content provider, then you may reflect those things, right? Content providers, cool, we have activities, content providers, one missing. And we actually talked about this missing one last week, not the week before. So all that stuff was the week before. There was storage. If we want to do something in background and not using async tasks, what's the artifact we need to use?
Services?
That's right, Android service, yep. So literally a service that sits in the background, does long-running tasks and is autonomous. Similar, the equivalent to the activity, but not the foreground activity, yeah? So whereas content provider is just storage, but it doesn't do any logic or whatever else. Just basically think about it like pretty much like an SQL database, but it could be anything behind it. It could be networking behind it, or writing to file systems or web services, right? So it's not tied to a particular solution. It's just an abstraction for whatever you want to do, right? So it's all programming APIs basically, as opposed to concrete solutions.
Is it more like interface, not the storage itself? Or?
That's right. It's an interface definition and a service as well, right? So it's like it gives you as a container, and you have this onCreate method and a few other ones if you want to, but you need to implement the UI or link the UI and so on, right? Cool. All right, we have 3 of them, and the last one of them is broadcast receivers, and they're actually, I think, one of the most interesting ones from an interactivity point of view, and actually, yeah, mobile device point of view, I guess. Because it's really about interacting with the environment. So the other ones are all autonomous components, but you kind of need to activate them. You need to, press the start button and they do stuff for you. But with the mobile phone, you dealing a lot with notifications, and want to be notified once you're on a new network, or once you have GPS access again, or you're in proximity to something, and so on. And all those events basically that you want to monitor, they will be managed using broadcast receivers. So a quite important concept, and they're basically the 4th component that you want to know about architecturally, and we talk about them a bit. So it's the idea is that events that are either user-defined or system-defined can be listened to. It's like, think about it like an event handler, pretty much, and then acted upon based on the invocation. So the principal operation is quite straightforward. You need to have a broadcast receiver that registers to a certain event. Yeah, events are uniquely identified by a string, basically, right? And they're system-wide valid. The event instance then is represented as an intent, and I go a bit deeper into intents in a second, but the idea is it's not just the fact that something happens, but possibly you also get payload associated with it. For example, you get a text message, right? Then there's the fact that you actually get a text message, plus you probably want to see the content as well, right? So you need to have some payload as well. That's why we're not just sending a string or something like that, but there's actually a fully fledged intent as a kind of data unit. So when events happen, they are broadcast to a system to some extent. And again, they can be produced by you. You can broadcast to a system, but also the system itself has predefined events that you can listen to. And Android then iterates through all the broadcast receivers that are currently registered and checks whether they're actually listening for that particular event, right? So it's what's happening behind the scenes, basically. And then they invoke those broadcast receivers, because they're quite straightforward. They have one method that's called onReceive, and receives an intent, and you can do stuff with it, right? So you, whatever, the sky's the limit-ish. But what are potential challenges, problems, if you do that? Just show you an example of a broadcast receiver, how it looks like without full implementation, but just for some inspiration. Let's assume this one here is the broadcast receiver. So we're extending broadcast receiver, and then we're overriding the onReceive method, and we get the context of the application, right? So you can access context-related information from the application package, but also the intent that actually manages the payload. So what is a possible challenge? It's not super intuitive, but we talked about the problems that we have with priorities and application components. Yep.
Maybe some kind of the race condition if 2 receivers are doing different things with the same context.
Yep, that's cool. Yep, that's what we talk about this as well. Yep, there's that issue. Yes, yeah. But if you think about processing intense operations, what was one of the constraints that we had both in activities as well? Well, if I'm receiving an event, I probably would be inclined or motivated to do all the operations, right? The business logic that's going to happen in that receive method, right? Could that or not? How would you do it then? That's cool. I mean,
I'm not sure if in Android this is some kind of like global observer.
uh-huh.
So if you can bind some of your private observers to the receiver itself, like broadcast receiving being a subject at the same time. So you could have some external services that the receiver only changes its states,
Okay.
and the external observers will take the rest of the.
Okay. I see. Yeah, you want to delegate the operation somehow, right? So I think.
Yeah.
Yeah, somewhat. So, but remember the one of the issues that we had when we had long-running tasks, we are not supposed to do them
The main thread.
on the main thread, so, right? And this thing operates, surprise, surprise, on the main thread, so of your application. So the problem there is, yep.
Also, then it would be nice to end this on receive as soon as possible, and then the other background task can take over.
Exactly. That's precisely the point. So we have the same limits as we have with activities. If you have like 5 seconds of in the most conservative configuration, if we have long-running tasks that exceed 5 seconds, you get an ANR, so Android not responding exception, then you kind of screwed basically. So you want to do as little as possible in that function. You need to kind of immediately delegate heavy load to other functionality. Of course, you can send a toast or something like this, right? So do the quite simple stuff. In fact, toast is really good for if you don't have access to your logcat and you want to do some debugging. So toast make text, and you can use the context and say stuff like, okay, received event. But for anything that's remotely more involved, let's do a long and just call show on it. So that's fine. But if it's somewhat more involved, you need to delegate it somewhere. So which are the candidate components you could use to delegate work to?
Service.
Exactly, right? So that would be a good candidate. So that's where you as an application developer come in. Now you kind of need to tie up what we talked about, right? All different components and how they're linked. Because yeah, there's not the way of doing it. So it really depends on the application purposes, right? Service is the obvious one because you're delegating now all the background activity to, non-visible activity, I would say, to a service functionality. So that's something you can do here. So you say start service and send an intent, to start a service and forward the intent if you want, right? So, and do some simple operations here, which like notifying something or creating some sort of toast or things like that. That's right. What other alternatives would we have in principle? For delegating the work?
Maybe content provider if you need to get something, but then you probably, I don't know how is it, busy waiting or something
Exactly.
to get from the content provider. So it will be the same as doing the stuff himself.
Yeah, that's right. That's exactly. I agree. It's not optimal. A content provider is a bit of a tricky one. You probably want to delegate it to some sort of service as well. But one of the important things is don't start activities from the broadcast receiver because that's usually taking too long. So you're exceeding your ANR. That's undesirable. And but the other way you could do it, you could in principle use asynchronous tasks, right? No? No? Okay.
Yeah, but you say that it's not this one of these main components.
That's right. But yeah, that's right.
So
That's right.
It is a solution, but not as a
Yep.
service. It's a big component.
That's right. So it's a kind of a lightweight solution. Service is a bit more heavyweight, right? Because the proper application component. This one is really like generally for operations that only run once and are gone afterwards. So not a long-running activity. But there are some challenges with async tasks, which we talk about in a second. But let's just bear that in mind for a second and look at the broadcast receiver principles in more detail. I gotta come back to that point. So about what to start there. So that's basically a typical broadcast receiver signature. You have extension of broadcast receiver. You have the implementation of on receive. You do stuff there. That's basically it, right? So no magic there. shouldn't hurt. So how does it work in when you register or when you create a broadcast receiver? Well, obviously you need to register it somewhere, and again, every application component needs to be registered in the manifest. Yeah, that's the only place where things are really tied up, where you see all the application components that belong to a particular application. And again, the broadcast receiver is one of them. You use the identifier receiver and then the receiver class that is relative to the namespace or package your application sits in. And you have the notion of so-called intent filters. And this is precisely the definition of the event you're listening to. So when the system sends an event of that type, so Android Net connectivity change. So if connectivity changes of the device, I don't know, you lose, for example, internet, or you lose mobile devices and so on, then you get a notification. As far as the content goes, you will always need to look into the specification for a particular event, right? So to identify what payload you get, what will be the information you get along with it in order to process it. So it's not entirely loose in terms of its binding. You still kind of need to know the semantics of the event that's actually happening. But in principle, the idea is there that you can tie them up to arbitrary events of the system, right? And may it just be to display, hey, there was a connectivity change, without providing any further information, right? In addition to the static registration in the Android manifest, you can also do it dynamically. What would be an advantage of the dynamic registration?
You can make as many as you need for any number of dynamic allocated tasks.
Cool. Yep. So that's cool. Yep. So you actually can define them at runtime. So depending on what needs to have, for example, processing intensity, right? So you can essentially add multiple receivers and then link them all, right? So you do 20 as opposed to 1 for whatever. I mean, I'm not sure it's reasonable, but you're right. You can do that. That's cool. Yep.
Probably you don't need this broadcast receiver every time, and just like when you are connecting to connected, you probably can have some activities functionality depends on this one.
Yeah.
And then you can just create receivers, and they will listen on some network activity.
Yeah.
But they are not necessary to be on the list when this activity is gone. So you can just probably garbage collect them somehow.
Okay, yeah. So that's right. So it's another point. It actually, and you're hitting the right thing, is performance. Because if you register them in the manifest, they're static, they're system-wide available across the entire runtime of the device, right? You may not necessarily want that because, as I highlighted, the principal operation, when an event happens, the Android OS goes through all, right? So through all possible receivers and checks for each of them, does this correspond to the, intent filter basically here that's defined as part of the manifest specification. So that's quite expensive, especially if your receiver doesn't do anything actually. So I mean, in this case, right? So for example, you only selectively listen to it when your application is running or whatever else. So it would be a bit of waste of resources. So it's in the meantime preferable to do the dynamic registration at runtime. So the idea is basically precisely as you see in the code sample here. So you define an intent filter, so the inner part of the XML you see up there, and add a particular action that is part of the intent filter. You can add more elements to intent filters, we talk about in a second. And then create an instance of the broadcast receiver and basically register that receiver in your context with the associated filter. Right, so the last line of code here, so you register receiver with my receiver instance and the associated intent filter.
And it leaves as long as activity.
They leave it long.
Or service.
That's right. So it's tied to your process in which your activity lives. Yeah, but the you are kind of responsible for managing it at this stage, right? So you would want to, for example, have a registration in onCreate, right? But if you, for example, destroy your application, right, on pause, which precedes the onDestroy, for example, you want to unregister the receiver.
So do you need? So if you, for example, register a receiver, it's getting on this list that Android goes through.
Yeah.
But do you need to manually remove it from it, or will be destroyed out, removed from this list automatically when you quit the application or the service or the asynchronous task?
The broadcast receiver semantically is attached to the process, so that is activity or service or anything else that's running. Because it's all those containers are still running by default in one process, right? So multiple activities, because it's kind of a second abstraction level, and this would survive the activity you're registering it in. So if you want to remove it actively, right, as opposed to having the swipe approach, right, where you go into your background activities and remove them by swiping them away, which would kill them, you would need to actively manage it by saying unregister in your activity. That makes sense? So because you can have an activity and service, activity could vanish, service could still run, right?
I just think about a scenario that you have, for example, you get the contact to the internet.
Yeah.
You start a task that, or activity that's cooperating with some network resources.
Yeah.
And I'm just making this receiver to operate as long as I'm online, but it's not my primary activity.
Yeah.
So if it will die and die off in some point, and I will have to restart it, will this receiver be still registered, or will it be gone?
If you are starting from the same process, so for the same application, if you like,
yes.
right? If you then it's still there, yeah. But if you are removing the the application in its entirety, then you need to re-register it. That's the idea. So that's the good and bad part about it, basically.
So registering the receiver does not prevent from killing the background activity or something. Because when the activity is on this background, it's not used, but it still has a receiver. So it actually this says nothing. It's only a receiver.
Yeah, but the receiver would still be registered in that case. Yeah, until you swipe it away, like in your context menu. You know that if you kill the entire application with all the associated components, then it's gone. So you can keep it this way. So but preferable is that you manage the life cycle yourself, because for all you have basically three main, or let's say two main application components that are relevant for your process, which is activity and service. And for both of them, you can manage the life cycle. So in both cases, you would be able to identify, okay, if that dies, do the following to my receiver, right? So kill it.
Yeah, I was thinking about just like this: that you start an app that is the only responsible is to be notified if it's someone pushed a message, for example, to the app, and I don't do anything in this app. It should only have the receiver. It's the only functionality. A receiver that could start some event.
So if you only have a receiver,
yeah, I don't need anything else. I need only a receiver that, and it's the only only functionality of the application.
That's a tough one. I'm not sure if you can actually do that, because you need at least an activity in your application definition. I'm not sure if the system would actually run the application that you're creating, right? It would imply that you have a manifest in which there's nothing, basically.
I just think about some work around this this push to mobile app activity that it needs to be steered by the Google way, all this in the Android. Yeah. And if I can create my own receiver that will just react on some event without going this.
So yeah, in this case you need to use the manifest, because in this case your application wouldn't be running, right? So if I get it right, you want to start the application, right? Now then you need to go the static way. So you need to necessarily register in the manifest, because then it's registered system-wide even before your application actually starts to exist, which is a bit of expensive, but it gives you the opportunity you're looking for, saying, okay, if there's a system and start this entire activity, whatever is contained in it, right? So, sorry, application is different. Application is a big thing in containing all the application components, activities, one specific, or you can have one or more activities in an application.
But then I cannot turn it on and off this listening activity.
That's right. That would challenge you. So, yeah, well, it depends on the application complex, how you possibly use it best. That's right. So, has both advantages and disadvantages. We talk a bit more about intent filters, because you can refine it there as well, as we'll see in a bit. Okay, So looking at the properties that we have, this is directly from the documentation, of course. The idea here is that the Android manifest has, again, a lot of options that you can specify, similar to services. So should the receiver, for example, listen at boot time? So direct boot aware means before the user actually logs in, before he or she unlocks the user interface and interacts with the device, should the broadcast receiver be listening? So it would be one of the options. First of all, second one, is it enabled or disabled by default? So that's another one. Exported implies, can it be called by other third-party functionality? So that's quite neat, because you may constrain that as well. Yeah, like label resource, blah, blah, all that kind of stuff. Permissions, so the permissions needed to use that broadcast receiver. And the process name. So it's running, it should be running in a dedicated process. What should be the process name for debugging purposes? So it's easier to find in the Android monitor, basically. So there's some options here that are quite rich in terms of specifying in the manifest, though. It's only happening in the manifest. Okay, so coming back to the long-running thing problem, because that's quite important just to think about this. So broadcast receivers run by default on the main thread, right? So as soon as an event happens, the broadcast receiver goes to the main thread. And the idea is that the main thread is basically never interrupted, right? So because this way you can have an atomic execution of the on-receive method, right, without fearing interruption by the operating system, unless it's like, you know, your phone is dying or something like that. Because the active task will never be discarded by, you know, garbage collection or some sort of memory management that Android does, right? So, but only while it's receiving. But that's also a reason why you keep it as short as possible, right? Else you have the ANR problem, and you want to minimize the execution, the time in on receive. So there's different pathways for long-running behavior. Async tasks to some extent, we'll get to that. But what are the possible problems with asynchronous tasks? I mean, it's good that you didn't pick them in the first place, which means you guys are experienced Android developers, or you didn't think about it. So I think it's the first one. So why shouldn't we, but what's the problem we could potentially have with async tasks in broadcast receivers? Well, asynchronous task, the problem is that you move operations in a background task, but it actually wants to interact with the main thread again, ultimately, right? To, for example, produce a result or something like that, or show progress updates or any of that. We had a brief skim at that last time. However, if your broadcast receiver is no longer active at that time, or any activity you are running or your service or whatever, then it's pointed to nothingness. So it actually can't return any of the information. So if your broadcast receiver has finished executing, meaning exits the on-receive method, then the async task has no way of sending information back, basically, to the system.
Starting an event that will start a
Of course, you're right. If you don't return to the, that's right. If you don't return to the actual event and you're independent of that one, they could launch another intent or event or whatever else, right?
So the results.
That's another way of doing it, but I'm not sure if it's inherently simpler or more complicated, because doing it this way, I don't know. So that's the main challenge there. So either you so the only way of doing it is some functionality that allows you to do that. So I'll just show you how it looks like without doing an example, but if we have time, we explore some of the other examples. So you basically, in your broadcast receiver, in your on-receive method, you call go async, and what it returns is what's called a pending result. And then you do whatever you need to do. In, you know, here it's the example of a thread. It could also be a conventional asynchronous task or whatever else. That's just how threading is done in Java. So, but it obviously also works in Android the very same way. Asynchronous tasks are a bit richer. They provide you more functionality. But the only thing you need to do eventually is to call pending result finish, right? That's the key thing. So anything between the start of the on receive and the pending result finish will be executed if you call go async. Yeah, but constraint is you're still tied down now to 10 seconds of maximum time of execution, else you get an ANR, because again it's still foreground. So the attention is still on the broadcast receiver, even though your task may be running in background, because it waits basically for the return value, right? And only then finishes the broadcast receiver. So you do whatever you want, and then you just say pending result finish. It's pretty much a bit like database commit, you know, where you actually, where you say, okay, now the operation is technically finished, do whatever you want afterwards. So it doesn't necessarily imply that you have any results in the pending result or whatever else. It just said you can. It just says the operation is done now, you can die, basically. Yeah. So that's your way around it if you want to use asynchronous tasks or threads or whatever other approach comes to mind. So, but by default, I think the use case is to start services. So you actually delegate whatever you have, you intend, and send it, you know, to a service, start a service, and process the data there, because then it's in the background. You know, you can take all the time you want, and you don't fear any execution limitations. Basically, that's the idea. So it's quite straightforward. It's not big magic there, and I think I have a selection of intents. Yeah, we get to that in a second. Some few aspects. Yeah, some considerations when you're playing with them and implementing them. So the for debugging purposes, there's an interesting flag. It's called the intent. Yeah, well, if you set a flag debug locked resolution, so it will actually help you resolve, or it will explore how an intent actually finds its way to a broadcast receiver, how it works through the filters. So you can actually debug your filters, your intent filters, whether they're properly set up. We see that in a second. It becomes a bit more important there, because when you set a more complex intent filter, then you'll see it can become reasonably complicated. The other flag you can set is to treat the broadcast receiver inherently as in the foreground in its entirety. So you can be very explicit about it. Yeah, by setting that flag. One aspect is that you should not, I leave out the first point right now, we talk about this in a second because we didn't talk about implicit intents yet, that you shouldn't start activities from on receive. So that's the idea. So because it takes long and will basically extends your foreground activity, like foreground execution. You shouldn't be doing long running tasks, or avoid them entirely, or delegate them as far as possible. And one of the other aspects that's quite important, if you write a broadcast receiver the first time, you probably realize you may not receive what you want. And it's oftentimes because there's some changes in the system behavior. Here it's quite important to actually know which operating system or which Android version you're developing for. For example, in Android 8, the idea that system events can be listened to has been considerably reduced for performance reasons. So they nearly, unless your broadcast receiver is explicitly notified, there's very limited opportunity to actually listen to system events nowadays, which is a bit of a pity. But so this is the Android provided events, not the application provided events, right? That sit on top of it. But the idea is basically it becomes too expensive to, distribute all the broadcasts and checks against all the intent filters and so on. So it's an efficiency decision that has been made, in particular in Android 8. So it may actually happen that you write your broadcast receiver and works well in Android 7, but suddenly doesn't work in Android 8 anymore, right? And that's where it becomes nasty, so you need to keep an eye on those things. The action you could still listen to some listed here. I'll just bring on the website and you get a comprehensive overview. Is reasonably nice. It's kind of limiting, obviously, the functionality that you have in Android out of the box, but it's made for two reasons. One of them is obviously performance. The second one is security, because your potential applications that you install, download, and so on cannot just listen to any obscure system event and do stuff based on it, but they actually need to be either explicitly addressed or rely on a broadcast that is related to another application, so a non-system application. So so that's the change in Android 8. So the idea is that you can't no longer use them explicitly. So locate change is one of them. If you access a USB accessory, you can still use it. Connection state is still accessible. So that was the one we just talked about, which is quite handy to have. Carrier change is one of them. Event reminders you can still do, so you can listen to your calendar. That's still fine, and you can listen to any thing that's happening to your media, here in particular SD card. If it's removed, added, or whatever else, you can respond to those events. And if you receive a text message, for example, SMS received action still works, and WAP as well. So Marius talked briefly about WAP, which was the dated variant of the pre-internet, the mobile version of internet pre 3G. So you can still respond to those events, but that's pretty much the limit. So other than that, you need to explicitly specify it. At this stage, it's probably, before I move to intents, yes, what I also will bring up, and I put those links in the slide set as well. One of the issues with intents in particular is the issue with the intensity you're receiving your broadcast receiver is that you need to know this, the data it carries, right? The data they carry. So it's quite worthwhile to look at that page here. It's like the intents common page, and it basically gives you an overview of very commonly used intents. For example, if you want to set an alarm, what's the action you're possibly listening to? What is the data you're actually getting? What is the type of the data that you're getting? What are potentially extras that you're getting? Did we talk about extras and intents and all that kind of stuff? Anyway, so it just describes the payload that you're basically getting associated with that. Cool. So to complete this whole picture a bit better, let us briefly talk about the idea of intents, to clarify what they are, what the structure is and so on, because we use them quite implicitly. And the idea of an intent is basically to send a message from, well, to express the intention to do something, right? To express the intention to do an action, for example, to start an activity, to view a picture or a website or whatever else, things like this. And we have two types of events we principally operate with. That's the explicit one. That is the one that actually names the entity you want to launch. In your case, you named, for example, in intents, you named the service that you, for example, want to start, or your activity you want to start by class name, right? So that's an explicit one, because you say, okay, I want to launch you as an activity, right? So whereas the implicit intent is something you find in Windows quite commonly. So you want to open a text file, for example, but you're not explicit about the application you actually want to use, right? So it comes up with this selector and says, yeah, hang on, but multiple applications can do the same thing. Which one do you want? Yeah. So in this case, you're not explicitly resolving the application or the application component you want to use, but you're just telling the system, I want to do that functionality. Tell me how to do it, right? So, and then you can programmatically, or as a user, pick what you want to do, right? You saw those menus, those chooser menus coming up, where you actually need to choose which application to use to open something. So here's really, the second one is really more looking at functionality. The first one is concrete about the application component you want to launch. Yeah. So that's the two principal approaches. And the structure of an intent generally looks like this. So we have an obviously they don't necessarily all need to be populated depending on the characteristics, but it has an action generally. So that's the data structure. Could be an action view or action send. So action view just says, I want to view something, right? But it doesn't necessarily tell you at this stage what it is. This will only be clear from the context that is the data, for example, right? So if you have a data path in form of a URI, meaning some sort of uniform resource identifier that is identified by its format, by the format you pass it to. In this case, I passed, whatever telephone number to it. By the way, there should be quotation marks, but this PowerPoint thing resolved them in this weird way. So if you have a telephone number, then the system will automatically infer that if you press action send, that you probably want to send a message or something like that, right? So that's the idea. So application needs to be clever enough to link action and payload data to have draw some conclusion based on that. And a further element is the idea of having a category, and here you can have one or more categories. So the idea is that you can refine your choice of what you want to do. For example, you can say we want to watch a web page, but you also want to browse the web page. Have a browser-style application that allows you to use a web browser to represent it. For example, you want to view an image. That's probably a better example. And you say category browsable. It will open it in a web browser, right? Because it has the browsable characteristics, and they can use it as a starting point for further navigation. So you can be very specific about the property of the target application that the target application needs to have. Yeah, the action is what do you want to do. The category says what should be the kind of application you want to deal with: a browser, a launcher, whatever else. So, and in addition to this one, we have the extras. And extras is nothing but a hash map of key values that are up to you. You specify the payload that's associated with this. So you need to indicate the keys and associate the values and so on. But that's just really up to you. So you can use as complex data as you like. Yeah.
Is there a limit for?
I don't know, but I don't think so. So I never had the issue. You obviously don't attach a massive set of data, but it's more really like in the calendar example, it's quite reasonable. So for example, you want to attach the year, the month, the day, weekday and stuff like that, right? So that's kind of the data you can't actually put into a structured data URI, right? And instead you just pass them as keys. So the target application then needs to know what keys do I have. Of course, you can also just display the keys because you can see what keys are in the extras contained and then access them. But your target application needs to know the meaning of the individual keys in order to process it, right? So it's a bit semi-tight coupling there, right? So because you need to know quite a bit about the intent structure to process that one. Yeah? But think about it for now, nothing like it's basically just a hash map implementation that backs the intent. And then in addition, the last thing are some flags. The flags basically just tell you about how the intent is going to be processed. So if you want to do some kind of meta information of how an intent is to be used if it started as a new process or in foreground or something like this. So that's just the option you have there. Just to highlight the example, we can see if we can come up with a very simple example for an intent. Let's see if I have one here, but no, I don't. We just make something up. So as before, so basically if we have a telephone number, for example, in string representation, number, I don't know, +47, and then, hang on, it needs to be a string. We can just create a new intent equals new intent, and what we want to do is, now I need to look it up, just try my luck here. Content intent. That's the one. Try that one. So that's the action call. Sorry. Touched my mouse pad here, and then we need to pass the URI data. So we need to do it as a URI. We just say URI passed, and that takes string as an input. Do we need anything else? No. So we don't have any other specific characteristics. So we can just say start activity because we want to say it's a foreground activity you want to be dealing with, and you just pass the intent and see what happens. So I think I need to pass the context. May have forgotten that one. Application context. What am I missing? What does it say? Ah, very nice, cool. It reminds me of something I need to do. That's pretty cool, I didn't know that. So actually, in order to, the system infers already, hang on, you want to do a call, but you actually need to have the permission to do that. So obviously, if you do some intents, there may be permissions attached to the target activity you're launching, right? So in this case, placing a system call, a phone call, so you would need to add the particular permission in the manifest. So if we, not sure if it did it for me or possibly not. Ah, it did here, right? So uses permission, enter permission call phone. So now that should actually work properly. So that's quite cool.
No, I think you need to add the try catch.
The try catch. Yeah, that's the Android standard way, I guess. So right, so you can do the check whether you want to actually. Yeah, all right, and if that's successful, then you can do that. So let's do that.
I don't think you need to return afterwards.
Well, we have much to do. You're right, I don't need to return up. Hang on, that's the, is that, that's permission. No, it's only started if it's not granted. I want to, no, you actually need to return if in the unsuccessful case, and do something else in the successful case. So else, no, that's right. So if it's unsuccessful, return from the system. If by either you have the permission or you got the permission by user from user, then you can just start the activity. So it's fine. If you say return, it just ends the on create and you'll be out. So let's see. Oh god, Gradle. Stream, you may be suffering. Not much output here. Check version context if not. If not having permissions, but I have the permissions, so I should be fine. Or doesn't it start the? Here it should ask me to do some stuff. Right, cool. At least I get some error. That's meaningful. So, failed exception main. That's cool. So what's the cause? No activity. Oh, right. That's interesting. No activity found to handle this intent. That's an interesting problem. Cool. So we're doing that kind of tries to resolve the intent, if it's not really able to do that. There should be the caller application on it. Are there not? It's probably right. It's probably not available on this phone. So what other painful thing could we do? Well, let's change our plan a bit. So it will work on your regular device if you have a caller application. So internet is the permission we need here. That's right. Manifest. Let's see what that does. Cool. So it actually does what we want to do. So here the intent has been sent. In this case, implicit intent, because I wasn't explicit about the application I'm launching, right? I just said, hey, web page, he doesn't really know, he has multiple options, multiple application, target installed application match that characteristics, it gives me the choice. So if you write your own application that also allows you to use websites using the view activity and taking UI as a data, then your application should appear here as well, right? So and then and then of course you can set system preferences, but fundamentally that's what's happening here. So in this case it tries to resolve Google, and it's kind of works. So okay, lucky us. But this is the fundamental operation. So quite straightforward. So hopefully as simple as just to send an intent. That basically. Otherwise, So I would need to have more applications to do more fancy stuff here right now. Because if you want to, for example, use the geo functionality, you could use geo and specify your latitude and longitude. I think in that order. So you would need to specify your, I don't know, I think it's comma separated without space there. That's right. So this would basically, and you would end up starting a Google Maps style application, and it would pin you to that particular location, for example, right? So that's the idea. But anyway, so that's just some of the functionality that's available there. So that would be an example for an implicit intent. The explicit ones, you guys know it, right? So you just say application class to be started, and then you off you go. So it's not much magic there. So one thing, if you want to write your own application that actually listens to the incoming intents, you, as mentioned before, you need to have an intent filter. And the intent filter is kind of the opposite to the intent, right? So this is used for resolving which application is actually responding to your intent request. And similarly here in the manifest, or again in code, you can do it either way, you can register those. And those are oriented based on the data structure of the intent. So we have action, data, category, extras, flags. I think those were the ones. But the ones that are relevant for the intent filter are those three ones: action, category, and data. And the rule is quite straightforward. So you register those with a particular activity that is attached to it. And the resolving intent, or the intent resolution, needs to have a match on all those categories. So so all those categories need to match. Only then your application is considered to be launched. If one of them doesn't match, it's not going to be launched. One of the other constraints is that you need to have a category default. So exactly that category, Android intent category default. But you can have more than one anyway. So but this needs to be one that is mandatory in your manifest. If you don't specify, it simply won't pop up in the launcher, meaning you need to be explicit about launching it, in this case. But again, categories are the only one that has more than one, where you can register more than one choices here without problems. What you can do though, you can have multiple intent filters attached to particular activity. So the entire, this section here could be repeated basically and then modified, right? If you want to have a different action, for example, you want to resolve but it may have different, let's say, payload data types, right? So in text plane, you may consume JSON data or XML data, whatever else. So then you could specify a separate intent filter saying my application can handle those and those intent requests for different data types. So you would replicate them, yeah? That's the only constraint you have there, really. So, yeah. So yeah, so basically it's the opposite of the intent itself. Quite relatively straightforward there. So I'm just thinking if I still manage to mock up a broadcast receiver here, if we're actually working one to see the full picture. Yesterday my laptop died unexpectedly, so was a bit out of a limb here, but we'll see if we get something going. So so if we have a broadcast receiver that does some sort of activity here, you need to specify it in the manifest, which it is down here. That's good. And then if you want to use the intent filters now attached to it, we actually need to write it out from scratch. So we say intent filter, give it a just intent filter, and then we have an action attached to it. Note, this is now a not an application, but an intent filter that a broadcast receiver that listens to events. So it's not specific about the contents. Mobile and mobile course, and I don't know. Let's call it example action. So you can actually make up your own intent filters. So cool. Obviously, the only thing that you need to match there is that the string is consistently used across your applications. So let's clear that up. Don't need any of that. So we have a relatively clean my receiver. So we registered it already, so we don't need to do that again. It's registered. Ah, yeah, it does. Yeah, basically that's all we need to do. So we just call create an intent with that particular content. So intent, whatever else, new intent, and now we need to attach the action again. That was edu ntnu mobile example action, I believe. So we'll check that one. So in this case, it's registered in the manifest example action. Here's the receiver. The receiver sends a toast. So and this is the main activity. So of course we can make it slightly more interactive by having a button that is supposed to just do everything when the activity starts. And the button is called button. That's quite creative. So in this case, we embed this into a find view by TID as ID button equals button equals button. And a bit of imports we need to finish. Cool. We need to set an on-click listener. In variation to the other approaches, the only thing you need to be explicit about is what type of target application component you want to start. Remember, if you write an intent, you want to start an activity, you call start activity, start service, or here send broadcast, right? Because that will just initiate that process. So, and let's see how it works, or if it works. Sorry, it's a bit slow-ish, but perhaps we get something. in the end, it always boils down to get those right. If you have typos here, then it becomes a bit critical. In any case, if you use those intent specifications, like those action specifications, I tend to use constants, so static final fields in Java, so you can easily reference them across different applications, so you don't have issues with typos, right? So I can show you in a second. So if I press the button now, and we'll see, yeah, cool, it actually worked. It received the event, right? So it sent a broadcast, and luckily I got the text right, so it basically just highlighted, okay, toast, you know, whatever, event received there. What I mentioned before, in case you are struggling and following me there, public static final string event. So just use a constant like this, and then you can reference it from across all your application components. So for example, you could even say here, I don't know, set main activity event. So then you certainly won't have issues with any sort of typos or the like. So it should still work, produce slightly different output. Yeah, okay. Only in the manifest you need to manually specify it, because they can't do that programmatically there. Same thing there. So then it spits out here the constant as well. So yeah, but that's pretty much it. So especially if you don't use the manifest for registration, but do it manually by saying register intent and so on, then it's very handy to have those constants ready. Otherwise you're probably out, you know, and probably face some challenges there. So if you have intent filter, new intent filter, and then you specify the action associated with this, and then you say register new my receiver, and then filter receiver is the name, right? Cool. So if you do it this way, then again you benefit from having a constant there around. So that's the dynamic registration as opposed to doing it in manifest, right? So in this case you remove the registration done in here. Cool. So that was that. So the last thing before I leave you in peace, oh no, I leave you with graphics. How wrong was I? Is to think about ordered broadcasts. So right now, if you have broadcasts, there's no implied order. So if you have multiple receivers and they receive events and so on, who knows, right? So you want to be able to control that as well. So what you need to do that in order to do that is to here's just the manifest-based approach. You simply specify a priority in the intent filter in the manifest. So in this case, priority of 1 and 2 for those examples. So we have two receivers here, receiver 1 and test receiver 2, and they have different priorities with priority 1 and 2, but both of them listen to the same broadcast, right? So in this case, this ordered broadcast, whatever it means, right? It's just a string. And the one with a higher priority will get it by default if the broadcast is sent using that method, send ordered broadcast. If you send it as a normal broadcast, the priorities don't matter. Even if they're specified, they'll be ignored, right? So you can selectively operate them in or process them in a fixed order or not. So that's the only way you can redo it, right? You can also specify priorities if you have a dynamic registration in from an activity or so on, as we talked about. That's basically it there. So if that ever plays a role, that's one way of going about it. Was there anything else I wanted to? Right. So the thing I kind of interrupted earlier was to look at particular intents, and now it probably makes a bit more sense. So again, looking at the action for setting alarm. So you want to create an alarm. The action associated would be action set alarm. If you want to have the fully qualified name of the this constant, then you just follow the link. But the point is, for an alarm, you don't need to have explicit URI data. So it's not something like create this alarm or whatever else, but instead, and also no content, content type is not specified either, but instead you do everything via extras. So we have a key extra hour, so it's the hour for the alarm, extra minutes, the minutes for the alarm. So those are the keys, and then you attach the values with those ones as well. So ringtone, whether it should vibrate, skip UI, but it's really specific to that particular intent, right? So here's an example of how it's set up. For example, you have a intent that just targets action set alarm, and then you put an extra. So basically a key value pair. So in this case, extra message, the message associated, hour, the hour associated with this, and so on. You can chain this because a new intent allows you to, or put extra returns the set of extras you can append to it, basically. So it's quite convenient for, you know, composing complex intents. And then you start an activity based on this one. Yeah, again, you need to have a permission set. You need to deal with this one. And if your example should operate based on an alarm, if your activity, for example, can set up alarms itself because you're writing your own calendar or alarm activity, which you can, right? So they have the same ability as the built-in one that's provided by Android, for example. You just need to satisfy this intent filter here by saying set alarm and having an intent category of default, which we need for intent filters if they should be automatically selected. And then your application is one candidate's application to receive that intent, and you can use this specification to set up your alarm in your application. Yeah. So it's quite important to be aware where you look up the structure, the payload structure for the intents, because that's by no means specified elsewhere. You just need to know it based on the documentation, right? And that's the case for various other ones. Use the timer, show all alarms. So in this case, action show alarms, nothing specified. You just run it and it should show you all alarms. Calendar information. So here it's different. You want to add a calendar event. So here the idea is that you need to have an event content URI you need to produce, and a MIME type that you need to satisfy, and some extras, and so on. So for various different intents, you find the characteristics here. If you want to take a picture, for example, video or image, your action would be create image capture, and I'm not sure if you need anything. All right, yes, extras output. So the key extras output would point to the location where the application is supposed to store whatever you produce, right? So it just launches the camera application. Whenever you press then take photo, it stores it in that particular location. So you can also modify the location of target pictures you want to take. For example, you have your own app that has a nested activity for taking a picture or whatever else that you want to store with your application, so you can control that location as well. So, but I think you get the gist here, right? So cool, yes, easy, straightforward, right? So just using, I need to play around with this and do, and I bet there will be some permissions coming along across your way here and there. That's the fun of Android. But other than that, it's actually kind of reasonably straightforward, but you won't get around looking into the API or at examples. You had a question?
I was just wondering then, it's, you have an application that should take a picture.
Yep.
And actually you need to just send the intent.
Yep.
And then the Android finds an app that can take a picture, yep, and send the file to you.
Or to that location of
yes,
that space. Yes, that's right. So you can assume then when that activity returns, then there should be something there, or not. You obviously test
so you do get some errors if there is no camera.
Exactly. So
program.
Anyway, so yes, but this is an emulator problem. Or not, I'm not sure how this works in this one, I didn't try it yet. But on your usual phone, you probably don't have those issues. That's usually the borderline where you start moving away from the emulator and actually test on real devices. Every time you deal with sensing or any sort of environmental, physical computing in the widest sense, where you deal with audio, video, geolocation, text messaging, anything that has communication channels or sensors attached. That's where you need to switch. But yeah, fundamentally, yes. So So quite straightforward, right? So it can be a very convenient way of tying things up. But it requires you also to test across different versions because sometimes things change or certain intents are not permissible anymore, like I discussed earlier. So, but those are very stable here. But again, your application is a bit loosely coupled with the entire system, right? So it's not fully self-contained, and that's important that you need to be aware of this as well for your task. So here, that's precisely what you were looking for. If you want to capture a picture, that's pretty much all you need to do. Yeah, you launch that from your application, say that's the intent. Here's the appended path. Here's an example of how the extra output is written. And yeah, then basically just start this activity with the expectation of a result, and it basically requests this particular action. So that's pretty much it. And then it basically has a callback in addition to that one. If you start activity on result, once you get a result of the activity, this callback is kind of executed. You can do stuff, like you say, check whether things actually happened at that particular location, or do any other operation that you want to do on the return piece of artifact. So it can be quite neat for that purpose. So worthwhile testing and playing around with this. Yeah, cool. Any other thoughts? So I think you guys have been using intents quite a bit already, but now you probably can refine your use a bit, make it more, you know, advanced passing, more. For example, data via intents is actually quite practical approach. And use broadcast receivers. I encourage you to play with them a bit, just to get a feel how good and bad they are at the same time. I find them quite a bit fun, because that's the only way you actually truly context sensitive, right? Where you can actually sense environmental data. In all cases, it's really more like, okay, now we have a mobile application, but it's fundamentally the same you do on a desktop, but it always requires user activity. But you want to sometimes also rely on, you know, context information, which is the power of mobile computing in the first place. And broadcast receivers are the way to go there. So when they come together with intents anyway. I mean, all the application components rely on intents, but it comes particularly important with broadcast receivers. Yeah, as we saw today, I guess. Cool. Any other thoughts? That's not what I want to do. I wanted to show you. Cool. So basically just talk about whatever is available anyway. Broadcast receiver, there's one link missing on broadcast receivers possibly, but if you look it up, you end up there. And that's pretty much the overview of this functionality that you have available there. So feel free to browse and have a read. You get a better understanding. A lot of examples there. And of course, you need to look at examples as well, but be mindful for which version of Android they have been written. Yeah. So because there were quite some changes, I think most significant in Android 6 onwards. So that's usually a good cutoff, I guess, in terms of looking at features and borrowing code. Borrowing code, yes. But if you borrow code, reference it. So, yeah. Good. Okay, I think we leave it at this. You can wake up again. Welcome back to the world. On a Friday. All right.